This is complex numbers part 2. We're going to be plotting complex numbers in what is called the complex plane. Now, you should be doing this or these notes in your graph paper, and you set up the complex plane in basically the same way you would set up the the Cartesian coordinate plane, but instead of having like the x and the y-axis, you're going to have what we call, or what was the x-axis. This is going to be your real number axis, and what was the y-axis is now your complex axis. So this is where, or what we're going to do. On the real axis, we're counting by real numbers. So like that first tick mark is 1. This guy really is, oops, that's 2. Over here would be 3, 4, 5, 6, and so forth. Going on the left, it's just like you would graph on the x-axis, -1, -2, -3, -4. However, on the complex axis, you don't count by real numbers, you count by imaginary units. So going up 1 is like 1i, going up 2 is 2i's, going up 3 is 3i, 4i, and so forth going upwards. And you have the negative imaginary units going downwards. So this would be -i, this would be -2i's, -3i, -4i, and so on going down that way. So plotting complex numbers on the complex plane is as simple as plotting regular numbers on our Cartesian coordinate plane. So let's do a couple of examples. Part A, if I have 2 minus 3i, this is a complex number, and complex numbers have different parts. The first part here, this is the real part because it's just a real number. However, the part over here, this is called the imaginary part, because it's got the imaginary unit attached there. So if I want to plot this coordinate, what I do is I have to find 2 on the real axis, which is 2 to the right of the origin, and then I have to go down 3 on the imaginary part, and I essentially just put a point right there. That coordinate is 2 minus 3i. Think of it this way. This is almost exactly parallel to plotting the coordinate 2, -3 on the regular xy plane. The only difference is you plot the real part on the horizontal axis, you plot the imaginary part on the vertical axis, and it's really that simple. Let's do another one. If I have B, let's do -3 plus 2i. The real part is -3, so I have to go left 3 from the origin. The imaginary part is 2i, so I have to go up 2. So if I go left 3 and up 2, that is really that coordinate right there. This is -3 plus 2i. That's where I would plot that complex number. Let's do another one. C. Just the number 4i. Now this is a complex number, it's true, but notice how it only got the imaginary part. This is called a pure imaginary number when it only has the imaginary part. So if I want to plot that, think of it this way. The real part is 0, right? And then the complex part is 4i. So it's like plotting the coordinate really 0, 4. So that would be right up there. I'm going to try to make it a little bit bigger so you can see it. That's the coordinate 4i. And just for giggles, one last one. If I wanted to plot the number, let's say -5. Now this is kind of bizarre, but technically, if you wanted to, you can call that a complex number, but the imaginary part is not there because the coefficient for I is 0. It's like -5 plus 0i, if you will. So you don't see the imaginary part. It's only a real number, -5. So if I had to plot this, I have to go where -5 is, which is right there, and put a point. So that number is where you'd plot -5, just on the real axis. That's how you plot complex numbers. Thanks for watching.